Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video we solve question 61 to 70 of ISC Class 12 Computer Science set of competency based practice questions. So before we begin, it is a request to please subscribe to my channel, and all the other solutions for all the other questions are solved in separate videos. You can find the link of those videos in the description of this video, so make sure that you check the description of this video. Okay, in this video we solve question 61 to question 70. Okay, so this is question 61. Take a minute and give this a reading. Okay, so this question is about reading contents from a file and file reading. This is the first time after solving so many years of IC question papers I've seen this file reading question for the first time. And there was another question based on reading from the file, so I guess there will be a question based on reading from file using file reader, buffer input reader, or maybe scanner as well. Okay, so I'll try to add a video, separate video that explains this in detail. Okay, for now we need to solve this question. So what they're saying is you have a file name student.txt which has this data. Okay, and when they say this data is written in the file, your file is something like this. If this is a file, it's simple text file. It has basically 3 rows. Okay, it has data like Anurag, 90 and 95. This is your first line. Okay, and then it is Brijesh, just second name, then 95 and 95 again. Okay, and then Toshali, okay, the third name with 97 and 100. These lines, rows are not there, neither is the header. There can be header on the top, but it is not. Okay, so this is something that you have to assume out of the question, and I feel this is a little unfair because they just should have given something like this as for the text file. Okay, because then you start getting confused if this header is a part of the text file or not. Okay, it is not. Okay, because if you go through the question, right, they are trying to read each line, then they try to extract tokens. Okay, so tokens for each line include the name and the 2 marks. Okay, and then they do it as long as there is a line possible. Okay, that is why the first line is you're reading a line using buffered reader. So from buffered reader, either you can read a character dot read or dot read line, the entire line. Okay, so this is basically reading the entire line where into a string, and what string it is reading into, it is going to be t because you are tokenizing t. So whatever string that you are reading from this file, okay, the entire line is being tokenized using this string tokenizer. Okay, and there are questions on string tokenizer, string buffer as well. There were not these many questions on these topics in the previous year's papers. Okay, so the first one is going to be reading the line as long as it is possible. So you read line into t because this is the variable given is equal to the object of buffer data is br and the function is read line. Okay, all right, and you have to read as long as this line is not equal to null. So this is being equated to not equal to null. Okay, and this is something very standard. This entire code goes in place of 1. So this is your 1, t equal to br dot read line, open close parenthesis, that entire thing within parenthesis not equal to null. It means that this reading, okay, this reading is happening first, and whatever value is being read, which is a string, as long as it is not equal to null, we are running this loop. Okay, which means we are reading a line from this input file as long as possible. Okay, so then your name is, so if you have this line as input, right, so if you have Anurag, okay, let's take 2 marks, 90 and 95. Anurag is a, all three are brilliant students, god bless them. Okay, no sarcasm. Okay, so you have phone as the third token, fourth token. So next token is the function that returns the next token. So name is going to be the first token. You can simply say this 2 is st dot next token. So 2 is st, okay, which is a string tokenizer object dot next token, that gives you the first string, which is the name. Okay, then comes the third part. Average is, this is simply going to be 2. This, your 3 is simply going to be 2. Okay, divided by 2, that's it. All right, you write it in separate lines. For example, if you have to write it in the answer sheet, you do 1, then you do 2, then you do 3. Okay, for 3 you write 2. Okay, and for this you can write st dot next token. Okay, and for 1 you can write t equal to br dot read line, okay, not equal to null. Right, final part is this. So this should be closing the stream. So this is br dot close. Okay, fourth is br.close for question 61. Okay, now if you look at the answer key, they say fr.close, this is the file which is the file header, and br.close. But if you just simply do br.close, it will close the stream as well, because this is a stream. Okay, file reader is a kind of a stream. And there is a very long discussion on Stack Overflow about this, that when you're trying to close this buffer data, do you have to also separately close this file reader or not? And you don't have to, it is mentioned in the documents. So I'll try to add the link for the Stack Overflow discussion, you can look at there. So it is beyond your syllabus right now, but if you're interested, you can take a look at that reading. Okay, so question 61 is done. Going to question 62. Okay, so this question is about, take it a reading, it is about linked list. Okay, so there is a cart linked list where the node looks like something like this. So in your question 62, you have a cart. Okay, if I make this a cart, it has a cart number, okay, and a link to the next cart. Okay, all right, and your first, the head of the linked list is pointing to the first cart in the list, a linked list which is being processed. So this is the front of the queue, front of the queue. So when you go to supermarket shopping, right, the person at the front of the queue gets the cart processed first, and then the next cart, and then the next cart. Okay, so this first is at the front of the queue. Okay, and there are functions. So there is a first, there is a static counter to count the number of cards in the queue. If a card is being processed which is at the head and removed from the linked list, count will be decremented by 1. If a card is being added to the queue, count will be incremented by 1. Okay, all right, so we have view queue, we have add card, we have checkout card. Okay, so in view queue we simply view what the queue is. So temp is first, taking a temp variable pointing to first, so that it can iterate through the linked list. So if there are few cards, okay, let's just take a few. Okay, say card numbers, this card number is replaced by some value, some integer. Okay, this card number is some integer. Okay, this one. So then one more, say one more card. Okay, and the next is null. So the next of the last card is going to be null. So in view queue, your first is pointing to the card, you say first is pointing to the card. Yeah, flag is set to false. Okay, we'll see what the user flag is. And you say while temp is not equal to null. So whenever you set temp to first and you set temp to not equal to null, you are basically trying to iterate the entire list, and that is what we are trying to do. We are trying to look at the entire queue. Okay, because, look at each card one by one. So one of them has to be temp equal to temp dot next. So you can say for question 62, okay, one is, I not say equal to, because the examiner might think that it is a part of the answer. I simply say temp equal to temp dot next. Dot next is the variable name, right? Dot next, yeah. Okay, so one is done. So we have two. Two is basically setting the flag, because flag is starting from false. So the idea is that after this while loop, if the flag remains false, it means the loop did not run. It means temp was null. It means first was null. It means the queue is empty. Okay, and that's what it is. If not flag, if flag is false, counter is empty. If the flag is not false, it was set to true somewhere in the loop. Loop ran at least once. Number of cards are printed. Okay, so your 2 is going to be flag equal to true. Okay, so view queue is done. Then we go to add card. Card is being added at the end of the queue. If the new card comes, it will be added here. Card being processed, it is at first. Okay, so enter the new card number. Okay, you create a new card. Okay, see, if first is null, first is new card. So if the list is empty, if there is no card at all in the linked list, first becomes the new card. That's fine. Then you set temp is first, temp dot next is not equal to null. When you do temp dot next is equal to not equal to null, you are going till the last node. You stop, the temp will stop at the last node after this while loop is over. And again, there is no parenthesis after the while loop. It means this single line temp equal to temp dot next is a part of the while loop. Okay, so temp will stop at the last node in this case, starting from first. Okay, temp dot next is new card. That is what they're doing. They're adding a new card to the next. So temps dot next is now not null. It is some new card when you're adding a new card. And the next of this is null, because when new card was created, it was created using this constructor, which is setting the next to null. Okay, so this is okay. This is okay. Oh, we don't have to do anything. Add card. Okay, so then you go to checkout card. Checkout card. So this is for a view queue. Okay, and then we have checkout card. View queue has two, right? Okay, then we have checkout card. Okay, for checkout we have 1, 2, 3. Okay, Checkout is basically processing this cart. So this cart will be removed from the queue. Okay. So when you have to remove the head, you save the head and then you remove it and you also decrement the counter. So it says cart being removed is temp dot cart number. So temp now points to first. So your one for checkout is going to be cart temp equal to first. Okay. So there is a temp pointer used in add cart here. There is another temp used in view queue. Okay, but these all temps are local to these functions. So every time we use a temp in these functions, these are being declared fresh. So cart temp and not just temp, and cart temp and not just temp. Similarly, you have to do cart temp equal to first. Okay, pointing it to the first so that you print the cart number which is being processed, and then you have to remove this cart. Okay, so you say temp dot next is null and temp dot is null. So you are basically disconnecting this cart. So if your temp is pointing here, okay, you have to disconnect this and you have to make sure the first points here, because first will always point to the first node in the linked list. Okay, so you can say you are saying temp dot next is null and temp equal to null. So basically you are just disconnecting. So you can say first is first dot next, or you can say first is temp dot next. So first is temp dot next. Okay, so temp dot next is this and now first points to this, or you can say first equal to first dot next, or the other option can be first equal to first dot next. Okay, either ways it is okay, because first is also pointing to this first node, temp is also not pointing to this first node. Okay, so 1 and 2 is done. Then you move to the last part, which is, oh, cards, you do count minus minus count, right? Count minus minus, this is your checkout. Okay, so 61 and 62 are done. This should be 2.0. If that is double, let's see if the average value is double. Average value is double, so this has to be 2.0. Apologies. Okay, because otherwise we will get integer division, we'll miss out on the fractional part. Okay, so this has to be, if this was integer, you would do 2. If this is double, you have, because these two will make up an integer. Okay, because this is int, this is int. Okay, you have to make it 2.0. You may lose marks. Okay, so make it 2.0. Okay, moving on to question number 63. Okay, binary tree, identify its type. This is a complete binary tree. So there are three types of binary tree. There are multiple types. I don't think you have to know all the types. The ones that are important for you are full, perfect, and the third one is complete. So one, two, and the third one, that is complete. So this is a complete binary tree. So complete binary tree has all levels full, okay, except possibly the last one. So last level 3 is not full, all the others are full, right? And possibly they are filled from the left hand side, which is okay. All right, so this is complete. And full binary tree is where all internal nodes have either 2 or 0 children. A perfect binary tree is where all internal nodes have 2 children and all leaves are at the same level. Okay, so this part is done. Moving on. So it cannot be termed as full binary tree, because for full binary tree, all internal nodes have either 2 or 0 children. So this has only one. So if you remove this child or add another here, say maybe some new symbol, okay, okay. So if this has 2 children, it becomes a perfect as well. But if either this has 2 children or 0 children, then it becomes a full binary tree. Okay. Then size of the tree is 1, 2, 3, 4, 5, 6. And if the internal nodes are given tree B, for according to me it should be B, C and A, because root node is also considered to be an internal node, but the answer key says B and C only, does not say A. Okay, state any one condition of balanced binary tree. So a binary tree, okay, any kind of a binary tree is balanced if the absolute difference of the heights of left and right subtree at any given node is not greater than 1. Okay, so if this is the left subtree, if this is the right subtree, the difference is not greater than 1, so it can go like this or this, but the height difference should not be greater than 1. Okay, moving on, complete the parts. Okay, so this is obviously extends. Okay, so class will extend another class. In this case, yes, taking three values and setting this to 0. This is a data member of this class, so all these three values will go to the super class constructor. So you can say super. Okay, and you can pass these three values, sp, sr and st. Okay, and then invoke display. So whenever you want to call a superclass method, you do super keyword dot the name of the function display. Okay, so 1 2 3. Okay, in the base class is your account is your base class. Okay, and your derived class is simple interest si. Prototype of base class constructor would be public account. Okay, base class takes three values, double sp sr st. So you can say double sp sr, or you can say prt as well, double p double r double t. This is your signature for the superclass constructor. Okay, base class or superclass constructor. Okay, moving on. Okay, fill in the following keywords at right places. So 1 2 3 4 5 dashes. Okay, and you have 5 keywords. Okay, so whenever something like this happens, you have to understand that I1 and I2 are interfaces, because in Java multiple inheritance is not allowed. You cannot say class, say maybe C3 extends C1 and C2, where C1 and C2 are both classes. This is not allowed in Java. Java does not support multiple inheritance directly. It is allowed in C++, however. Okay, so if C1, C2 classes, you cannot do this. This is just not allowed. Okay, this is only possible if I1 and I2 are interfaces. So implementing multiple interfaces together is a indirect way to implement multiple inheritance in Java. Okay, it's a very standard thing. So when you are implementing multiple interfaces, this is going to be implements. Okay, so implements is done. Then we have void print info. So this is an abstract function. It does not have a body, so it needs an abstract keyword. So we say abstract comes here. Okay, then we have class s1. d2 obviously extends s1. Single inheritance is allowed. Okay, d2 extends. This extends is used. Then we have a show method in s2, and d3 extends s2. So obviously super dot show, calling the show method of the super class. Super is done, and we are left with protected, which fits fine, because a protected member can be used directly. Okay, can be accessed directly in the subclass. Okay, so data, which is a part of this class s3, is being used in the subclass which extends s3. Okay, so this question is done as well. Going to 66. Poem again, two different way. Okay, so this is method overloading. Okay, that is, you have multiple methods with the exact same name but different type and number of arguments. Okay, so even if you are passing two numbers here and two numbers here, these two numbers are double type. Okay, and these two numbers are int type. So you have a function signature double, and you have a function signature int, which are two different function signatures. In polymorphism, in method overloading, you cannot have two functions with the exactly same signature. You cannot have int and then again int. You can do int double int. Okay, something like that. Right. Okay, in this case, this is drive. Oh, this is method overriding. Okay, method overriding. Okay, method overriding. Forgive me for my handwriting. Okay, then defining keyword this and super with respect to constructor. With respect to constructor, so super keyword is used to call the base class constructor and should be the first line in the subclass constructor. Okay, this keyword with respect to constructor is used to call another constructor. What do I mean by this is, if you have a class, say, okay, class t, okay, it has an int data. Okay, you have a constructor public t that sets data to 0, and you have another constructor public t that takes a value d and sets data to d. Okay, so you can call this constructor from this by doing something like this, and you pass 0. Okay, that is when you want to set your data to 0, rather than directly doing this, you are passing 0 to this constructor which is setting data to 0. And right now you might say that this is an overkill. No, this is not. There are cases when constructors have so many lines of code, multiple lines of code, right? And there is there is in a way repetition happening, which you don't want, right? Because you don't want to repeat yourself when you're coding, right? So one constructor calls another with certain starting values, which in this case, uh, this constructor is calling this with value 0. Okay, then base class student derived class say later. Okay, so this is, they are saying that ICSC student is a subclass of student. Okay, so I use the word subclass, superclass, base class, derived class. Okay, similarly class it at multi levels. So this is not multiple, this is multi level. So it can be, so multi level, that is if you have a class say A, okay, class B can extend A, and then class C can extend B. This is okay. A extending B is extending A and C is extending B. That's okay. But you cannot do B and, if I have another say class D, C cannot extend B and D together. This is not allowed. You get a red mark here. This is just not allowed. Okay, it can extend one class only. So either D or B. Okay. All right. So you have to draw something like this to show what is happening. So arrow is pointing upwards, right? So we have shapes. Okay, put it in a box. Okay, so the subclasses are going to be 2D shapes and 3D shapes. So pointing towards the, yeah, super class, 2D shapes and 3D shapes. This is 2D shapes, D shapes, and 3D shapes. Okay, then you have triangle and sphere. This triangle is going to be a 2D shape. Okay, does not have a third dimension. Sphere is going to be a 3D space. Right? So 2D shapes is a type of shapes, 3D shapes is a type of shape, triangle is a type of 2D shape, sphere is a type of 3D shape. Okay, this is done, this is done. Moving on. Okay, this is K map, right? And I'm not very sure about the solution, so I'm gonna leave this for now. Okay, I'm not very sure. I did not. There are certain things I did not agree on. Maybe I'm wrong. I just gonna solve this separately. Okay. All right. So you have to reduce expression by K map. So let me just draw the K map for this four variables P, Q, R, S. So we have. So one is 2, 3, 5, 7, 8. Okay. 2, 3, 5, 7, 8, 10, 11, 12, 13, 15. 10, 11, 12, 13, 15. Okay, so we can have one quad like this, the other by overlapping can be this, and one pair like this. So this, for this we can have, okay, for this we can have this is S and Q. Okay, for this we can have this one, this is Q bar dot R. Okay, this one we can have P R bar S bar. Okay, so this is done. Then you have to draw like using NAND gates only, and the complements are also given. Okay, so that is nice. So what you can do is you can simply uh, pass all these into a NAND gate. Okay, then you have Q bar R. Okay, because complements are directly given, P R bar S bar. Okay, and then you NAND again. Okay, this will give you your, okay. Moving on, we have this, and you have to write the cardinal and canonical. Let's find the canonical first. So this is basically a B bar plus a C plus B C bar. Okay, so C is missing, so I'll do C plus C bar plus A C B plus B bar plus B C bar A plus A bar. So A B bar C plus A B bar C bar plus A C B bar plus A B C, right? Plus A B C bar plus A bar B C bar. Is any term being repeated? A B bar C, A B bar C, A bar B bar C. So A B bar C, A B bar C bar. Okay, this is taken. A B bar C, bar C bar plus A B C plus A B C bar plus A bar B C bar. This is your canonical SOP. Okay. Okay. So this is done. Cardinal is going to be, so cardinal is going to be uh so this is 1 0 0 1 0 1 1 1 1 1 1 0 0 1 0. So this is going to be 4 5 7 6 2. So sigma 2 4 5 6 7. Okay, this is your cardinal. Then we move on to this max term and min term in for f in canonical form. So min term is going to be a b bar c d bar. Okay, this is a min term. Max term is going to be a bar plus b plus c bar plus d. So this is your max term and this is your min term. Okay, last question for this. Okay, so you have to calculate f, which is going to be, okay, has an Aadhaar and no criminal record. Has an Aadhaar is A, no criminal record is going to be C bar. Okay, plus because any of the one. Then tourist is government employee. Tourist government employee is G, and as repeated is to in 6 months, which is V, plus tourist has an Aadhaar card, which is A, plus is order within span of 6 months, which is V. So F is AC bar plus GV plus AV. So your F is, so let me just draw the truth table. AC, GV, AC bar, GV, AV and F. So AC bar, so first 8 are going to be zeros, then C bar, so this is going to be 1 and then zeros. So we have 4 ones and then 4 zeros. Okay, GV, GV is going to be 0 0 0 1, right? 0 0 0 1, and then this pattern follows 0 0 0 1 0 0 0 1 0 0 0 1. And you have AV, so first 8 are obviously zeros. Okay, and then V, so V follows 0 1 0 1 0 1 0 1. Then F we have, this is all 0, this is all 0, this is all, this is 1 0 0 0 1 1 1 1 1 0 1 0 1. Okay, so this is going to be 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So what do we have to write now after the truth table? Truth table is done. Cardinal, so it is going to be 3 7 8 9 10 11. 7 8 9 10 11 13 and 15. 13 and 15 is your answer. Okay, and this is your question 70, and we do the remaining in the next video. So I hope this video was helpful and you like this. So if there is any doubt, there's a part you don't understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there's a question you want to solve or if it's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.